Let's see how to use the Euler integration method when we're given a grid of monitoring times that are not necessarily equally spaced. The ordinary differential equation that we want to solve is df of t dt is equal to the function a of t f of t, which is known. It is supplemented with the initial condition f of t0 equal to f0. So we know the value at t0 of the function that we want to integrate. We're also given a grid of monitoring times t0, t1, t2, up to tn. These are not necessarily equally spaced. So for instance, t1 is here and t2 is here. The value of the trajectory at time tn will be denoted fn. The first thing we're going to do is to define the integration steps, delta t sub n. This will be defined as tn plus 1 minus tn. We're going to put a subindex n here to indicate that the size of the integration step depends on time. So for instance here we'll have delta t0 and this will be delta t1. Tn will be the last step in the integration interval. The algorithm is very similar to what we had before. So all trajectories start at f0. The value of the trajectory at time tn plus 1 is given by this expression. A is evaluated at tn and fn, and then we're multiplying by delta t sub n. N is an integer that runs from 0 up to capital N minus 1. Let's see how the trajectory unfolds. At t0, the value of the trajectory is f0. At t1, the value of the trajectory is f1, which is calculated as f0 plus a evaluated at t0, f0 times delta t0. So that would be, let's say, that value. Now we do a linear approximation to generate the value of the trajectory at t2, which is f2, which will be f1 plus a evaluated at t1, f1 times delta t1. So that would be, let's say, that point here, and that's the trajectory. And we would continue the integration steps until we reach the final time tn. So this is the result of the Euler method when we have a variable size integration grid. In this case, we're monitoring the trajectory at time 1, 3, 7, 8, 10, 12, 15, and 20. Between each of these monitoring times, we just have a straight line corresponding to the tangent at that particular point.